Okay, we'll continue now, so you'll have to do your best to finish those. Right, so next lesson now, we're going to have a look at optimization. So these are practical problems. What we're going to do is use calculus to help us find the best solution to problems. Okay, so I'll give you an example. We'll go straight into an example. So this is a typical exam type of question. You want to manufacture a cylindrical can. Now the problem is you don't know what is the best height or the best radius to use. The only thing that you do know is how much you want the can to hold. So perhaps you want the volume of the can to be 400 centimeters cubed. That's the only thing you know, that your can has to hold 400 cubic centimeters, 400 cc's. So even with only this information, it's actually enough to work out the radius and the height. Now we need to be very clear on what we're trying to achieve. So if you're a manufacturer, you want to make the cheapest can possible, right? Which means you want to use the least material possible. So what is it about the can that you want to make minimum? What do you want the least of? Yeah, the area, the surface area. Because if you think about it, if you're making a can, what you're doing is you're taking a sheet of metal and you're folding it up to make a can. So the surface area represents how much metal you have to use. So making the area minimum is the best situation. I mean, you don't want to use more metal than you need. You know, you don't want to have this much metal folded up to make a can when, say, maybe only half the amount will do. Okay, so to be clear, your goal is to minimize the area. That's your goal. Okay, so the goal is minimum area. So that means we first should begin by writing down the formula for the area of a cylinder. So from middle school, the area of the cylinder is 2 pi r squared plus 2 pi r h. So you might be thinking, no problem, minimum. So what do I do for minimum? Well, we need the derivative to be 0 and the second derivative to be
less than 0.
No? Positive, yeah, for minimum. Okay. What's the variable here? What's like the x? Which letter is like the x? Well, now this is the problem. You have two variables, r and h. So you need to have only one variable, so we need to change one of them.
Get h in terms of r?
Yeah, well, you know here that the volume, 400, should equal pi r squared h. So which is easier to get out from this formula, r or h? H. Yeah, you can see, what does h equal? 400 over pi r squared. So you can change this into 2 pi r squared plus 2 pi r times 400 over pi r squared. Now let's clean that up a little bit. That will be 2 pi r squared plus 800, and what do I have? 1 over r. So that's r minus 1 then. Okay, so here we have a is 2 pi r squared plus 800 r power minus 1. Now we can get the derivative. Okay, so what is the first derivative here?
4 pi r.
Yeah, what is it? 4 pi r minus 800 r power minus 2 should equal 0. So you have 4 pi r equals 800 over r squared. If you just take that over to the right. Can we get the r here? What should I do next? R cubed equals 800 over 4 pi. So we've just figured out the best radius to use. it should be the cube root of 800 over 4 pi. Which is, what is it? 7.3 point. No, you can't both be right.
3.99.
Sorry, 3.99 it looks like. So I'll round that off to 4 centimeters. Now if I put that back into this formula, I can get the h over 4 squared. So what's 400 over 16 pi?
78.5.
78.5. Thank you. 7.96. So that's about 8 centimeters. So roughly speaking, the best shape to use is one which is 8 centimeters tall, roughly, not quite, and roughly 8 centimeters wide. Roughly, its radius is 4 centimeters. If we want to be more technical, it was 3.99, I suppose. So what you've just discovered is this is the best cylinder to make, because anything different than this will be more expensive than it needs to be. This is the optimum shape. This is the best cylinder that will hold 400 cubic centimeters. Uses the least amount of material. Now we want to check that it is actually a minimum. So the second derivative would be 4 pi plus 1600 or to the minus 3. Now that's clearly positive. You know, I don't even have to sub a number in, because 4 pi is positive and 1600 or minus 3 is also positive. So clearly positive, which makes it clearly the minimum, the cheapest shape to use. Okay, now we'll do another example now. When you write that down. So this was like an exam question. The next one I'm going to do is also very, very similar to an exam question. The only difference is in question 4 it's about coffee, whereas in the exam it was about DVDs. So changes nothing about the story. Okay, can I scroll down? Yes? Scroll down. Down. Yeah. Okay. So number 4 now, we'll look at it together. When the price of coffee at a coffee shop is €2, so when the price is €2, the amount that they sell per day, the quantity that they sell is 100. So when P is 2, Q is 100. Now, when they drop the price to €1, so when the price is €1, the quantity that they sell, unsurprisingly, is more. They sell 150 cups of coffee. This is all reasonable, isn't it? €2, they sell 100 cups. €1, they sell 150. All very reasonable and realistic. Okay. Now, obviously the coffee shop has to pay some costs. So you have something called the fixed costs. So this is the cost that they have to pay every day, no matter what. Let me just put in the euro symbols here. So euro, euro, euro. €70. What's an example of a fixed cost for a coffee shop? What is a bill that the coffee shop will have to pay every day?
Rent.
The rent. You know, it doesn't matter if they open or don't open. Regardless, they're paying €70. Another fixed cost might be, just the heat and stuff like this. You know, that's the fixed cost. Now, there's a second thing called the variable cost. So you understand, of course, if they make more cups of coffee, that means they have to buy more cups, right? They have to buy more coffee, buy more milk, etc. So the variable cost is how much extra cost there is for every cup that they sell. So that works out to be 33 cents. So for example, if they sell nothing, what's their bill? 70. If they sell one cup of coffee, what's their bill? 70.33.
So it's 70 plus 0.3.
Yeah, so we can kind of get a formula here going, yeah. So the first question is, I just want you to make a graph of the relationship between quantity sold and price of coffee. So let's do that part first. So on this axis I'll put Q, and this I'll put P. So when the P is €1, what's the quantity? 150. So it's up here. And when the P is €2, what's the quantity? 100. So that's here. So this is not a surprise. The graph is going downwards. As you increase the price from 1 to 2, you lower the quantity sold. Okay. I want you to get the formula here. So that's okay. That's 1, 150, and this one is 2, 100. So we want Q equals mx plus c. How do I get the m? That would be 150 minus 100 over 1 minus 2. So that's equal to what? Minus 50. Okay, so Q equals minus 50. Oh, sorry, that should have been P there. Q equals minus 50p plus C. How can I get the C? Sub in a point. Let's sub in this one. So I get 150 equals minus 50 plus C. So what's C? What's C? 200. So I have my first answer. I have Q equals minus 50p plus 200. So let's test this out. The coffee shop decides to set the price to be €1. So if I put €1 in here, how many do we sell? 150. Okay, that's fine. If I put in €2, how many do I sell? 100. Okay. What about if I put in €3? 50. What if I put in €4?
No.
Yeah. So at €4 there's no demand. We've reached the limit of what people are willing to pay in my coffee shop. €4 is the limit. Now let's go the other direction. Suppose I was to drop the price to 0. What's the demand? 200. So I'll have 200 people coming in looking for free coffee then. Now as a coffee shop, you need to try and figure out what is the best price to set. You know, you might think, I should make this smaller, because then I'll get more people, right? Yeah, but if I make it smaller, then I'm making less money because it's cheaper. So you might think, I'll make it more expensive. But then you get less customers. So there must be some point at which you can make the most money. And that's what we're going to have a look at. So let's go on to part B now. Find the formula for the total cost. Right, so total cost. There are two bills that the coffee shop has to pay. The first one, what do we call it? The fixed cost, and the second one, variable cost. So what is their fixed cost? 70. Now, for every cup they sell, what's their cost? 0.33. So this would be 0.33 Q. Every one sale makes 0.33 extra cost. So that's why I multiplied by Q. Because this is how much variable cost in total there is. Okay. Now, I would like this to be in terms of P, because P is the thing that we can adjust. So let's substitute this in for Q here. So you get now total cost is 70, plus 0.33 times minus 50p plus 200. So now we get total cost is 70. Oh, what's 50 times 0.33, please? 16.5 p, and then 0.3, is that 66? 200 times 0.33? 66?
Yeah.
Yeah, we sure?
Yep.
Yeah, okay. So, total cost is 70 plus 66, what's that now? 136 minus 16.5p. Yeah? Okay. Now, I want you to take this formula and tell me what is the total cost for the company if they set the price to be €4. What's their total cost? Work that out.
The total price?
If the P is €4, what's the total cost? Now that's not surprising, because remember, what did we say happens when the price is €4? You get no customers, so you have to pay your fixed costs, and there's no other costs. Right. Now more interesting is, what if we set the price to be 0? We get 136. 136. So you have to pay the fixed cost and the cost of making those 200 free copies. Okay. Right, next part now. So I've actually, next part is C. So of course we now need to work out how much money we can take in. This is called the revenue. And that's quite simple. If you sell a cup of coffee for P, and you sell Q of them, what's the total you got? P times Q. You know, if you sell Q cups of coffee at a price of P each, then the total is Q times P. You know, if I said you sell 100 cups for €2, what's the total you got? 200, obviously. Okay. Right. Again, let's just replace the Q here. What did I say the Q was earlier? Minus 50p plus 200 times P. Minus 50p squared plus 200p. Okay, that's the total revenue. Again, let's check this here. If I set the price as 0, how much money do I get? Make sense? Now, what should happen if I set the price to be €4? No, this is the revenue, the money that you take. Why? Nobody buys it at €4. So, let's put in €4 here. So, 200 times 4 is 800, isn't it? And then 4 squared is 16. 16 times 50 is minus 800. Minus 800 plus 800 is 0. So again, we've seen that if we set 0 or €4 in here, we get no money. Because we get no money at P equals 4, because nobody bought anything. And we get no money when P is 0, because nobody paid anything. Okay? So again, we know the answer is somewhere between 0 and 4. We're nearly figured it out. So if you're a business, what do you want to make maximum or minimum? Like in the last question, we wanted to make the area minimum. As a business, what are you trying to make? Profit. And what are you trying to do with your profit? Make it max or min? Max. So what is the profit here? Well, that's how much money you got minus the top cost.
Yeah.
You know, the money that came in minus the money that came out. Okay, so profit equals minus 50p squared plus 200p. What did I say oh, there it is there. Minus 136 plus 16.5p. So we have the formula profit equals minus 50p squared plus 216.5p minus 136. Now, we're at the last part where we can figure out the maximum profit. And just before we do, let's check this formula. If I set the price to be 0, what's my profit? Minus 70. I've lost 70 euros. So, no, it's actually worse than minus 70 because I have to pay I have to make all the cups of coffee, so it's minus 136. So this is quite bad. If I set my price to be 4 euros, I think this should work out to be minus 70 because I didn't get in any money, but I have to pay to make everything. Alright, so let's figure out what is the best price. I want the maximum profit, so what should I do next? What equals 0? No, not profit. No, you don't want profit to be 0. That's quite bad for a business. If you want maximum profit, what should you do? I know the first derivative. First derivative should equal 0. And the second derivative should be less than 0. Alright, so minus, what's that? Minus 100p plus 216.5 should equal 0. So that means p should equal 2.165. So p should equal 2 euros and 17 cents. Is this a maximum? Well, let's calculate the second derivative. That would be minus 100, which is negative, which makes it a max. So by charging 2 euros and 17 cents, this is how the business can make the most money possible. If it charges more than 2 euros 17, tries to get a little extra money, it'll actually end up making less money because they will have less customers. They might say, oh, let's increase the price to 250, we'll get more money. Well, you lost customers, and the amount of customers you lost cancelled out and made your situation worse. Okay? So this is, the company cannot charge any price other than 217. If they charge more than 217, they get less money because they get less customers. If they charge less than 217, they get less money because people are paying less. This is the optimum, 217.
If you want to find the quantity as well, sir.
Yeah. Well, I know it's not super realistic because I don't really think people will see a difference between 217 and 220. So it's not like some people will go, well, it's funny because I would. Some people would go, 220, no, this is an outrage, like, for example, in the canteen, they have bowls of porridge for breakfast. It used to be 120, and then they increased the price to 130, and then I stopped. I haven't gone since. So there will be some people affected by the small price change. Yeah. It just, if you don't see a difference between paying 220 and 217, that just means you are one of the customers they will keep. But they will lose some customers like me, and they will see their profits drop slightly. Yeah.
Sir, if you want to find the...
Yeah, so if we want to figure out the quantity, we can just simply sub that back into this formula here. Yeah, so what is that actually? Can someone just sub that in, please? The quantity will be minus 50 times 217 plus 150. What's that? 91.5?
1.5, yeah.
So it's about 92 cups. Now what I like about this one is because it really shows you the importance here. There are situations where you can be, for example, imagine you're the coffee shop and you're selling coffee for €2.50, and then somebody recommends you drop the price to 2.17. What will happen to your profit? Will you have more or less? More. Because this is the optimum. This is not the optimum. So if you move to the optimum, you can only improve your situation. So this seems quite strange that you can actually cut the price and get more money. You can see this sometimes. In sales. They cut the price, but the extra customers that they get more than make up for the loss per sale. Okay.
Sir, it's plus 200, not 150.
Oh, sorry. This is Oh, plus 200, sorry. So it's not 92 then, is it?
No, it is.
Oh, it is 92, okay. So it's just 200 here. I'll just give you one more example, not a calculation, but just an example that shows the importance here of optimization. Like, this is one of the most important things about calculus, is that you can optimize. So here's another interesting example. Okay. This is the percentage tax the government charges you, and this is how much money the government gets. Right. Government charges 0% tax. How many euros will they get? So we can all agree that there's 1 point here. Okay. Government charges 100% tax. Will it get a lot, a little? What will be its situation for how much money it gets? Gets all the money, huh? No. Gets no money. Now, let me ask you a question. Suppose I said, oh, there's a new job, and you can take this new job. The only thing is the tax is 100%. How many of you will choose to take this job? If you know that you will get exactly 0 euros? No one. So if you don't take the job, it means the government doesn't get the tax, right? So at 100% you actually get nothing. What happens if I increase the percent here a little bit? Government gets a little money.
Yeah.
So 1% gets a little money, 2% gets a little money, 3% gets a little money. But we know we have to head back down to 100. So I imagine that this graph would look something like this. So the job for the people in government is to figure out what is the percentage that will get the most money. Now, there has been some situations where the government was charging too much tax, and when they actually lowered the tax, they saw their money increase. I think Russia was in the 90s as an example of this. Okay. There are some situations where the tax is quite low and the government thinks by lowering it they get more money. So it's already quite low and then they lower it hoping that they'll get more and they get less because they think that they're over on this point. Okay. And the example here is always USA because the Republicans always feel like, oh, if we cut taxes then we'll get more money. I'm like, yeah, but that's only true if you're charging a lot to begin with, which they're not. So anyways, the calculus and practical problems, very, very important, and I need you to do all of these. Yeah. So can you start these for a few minutes, and I know what we're doing in the tutorial next week. Yeah. So do your best to get through these. They're all exam style questions.